Uses for this table. I mean, to me, it looks like a dental chair. It could be a number of different things.
Actually, that's something we started to look into. Is maybe this isn't just a table for specific hospitals because it's so low cost and easy shipped. It might be something that could come in very useful during a natural disaster for multiple uses. Maybe just as a bunch of hospital beds that can be used because the price is still so low, even in comparison to a bed. Dental chair, which you mentioned, is also a need that we've seen over in the third world. This table has not been designed to function as a dental chair, but as we mentioned earlier, the surgeons in the third world are very ingenious in the way they do things, and they'll make things work for them.
One thing that was established during phase 1, is this the last question? Okay. Sorry. We'll talk to you all day about this, trust me. One thing that had been established during phase 1 was this idea of the IKEA of healthcare. This flat pack, ready to assemble, low cost furniture, but surgical equipment furniture. And so one of the things that's continuing to be discussed is a suite of products. That this can have accessories, arm boards, there's stirrups, there's an endless amount of things that they also need to, that make things easier for the operations. And that this can be, all of the other pieces of equipment that you see in a room, in an operating room, the rolling tables and things, that the business model can really show expansion in that way. Not only to go other places besides Bangladesh, but also to go into other products and continue this. And that's one of the reasons that I think that we're excited about it as an entrepreneurship business model. Yes. Dr. Jameson. Oh. Yes, ma'am.
I just have one more question. What has this experience as a team meant for your education? What has it done for your world of learning?
This experience has been invaluable. Like working on a team with such different backgrounds. We have art students, we have business students, engineering students. If I were to build this table solely based on engineering principles, it would be able to support 5 tons, it would weigh 1,000 pounds. And I come with that design, and then the design student tells me, no, that looks terrible. That's the worst idea I've ever heard. Okay, back to the drawing board, and then we reevaluate what we have. So that working in a team has really been, and this kind of team has really been enlightening.
And going on that point about different backgrounds, I think one of the biggest things that made our team function very well was the understanding that even if somebody tells Chris his idea looks horrible, he's not taking that personally. We understand that we have a goal to get this table for $500 to the third world on a for-profit business model. So we all had that same goal in mind, so we had a very good playback with people taking the devil's advocate on an idea. So when we would brainstorm, somebody would bash it down, and that would make you rethink it, and then we'd come up with a better solution in the end. So that was just a great team experience, regardless of what disciplines we came from.
Also became very familiar with the sculpture department metal shop.
And each other.
Have you thought of sterilization of services between surgeries? How the materials that you reconsider using in that effort?
One idea, there's been a number of different things thrown about. Of course, they've told us, some people that have had on-site location experience have said to expect a hose and a scrub brush, and that, it's a very different process than what we expect. But in our, another idea that we had is some sort of dunk tank, because it is all so easy to take apart and put together, that these pieces, they fit into a 24-inch cube. Is there a potential that you could have something, a sterilization tank or something like that? And that would really be more exploration, research in Bangladesh, and really identifying closer with the hospitals and their existing conditions to get a better idea. But the coatings that we're looking at, there's a lot of technology out there for inexpensive biomedical coatings, similar to powder coating, but different makeups of the plastics and things that are really, meet all of the requirements. And so that's kind of the direction we're going.
Basically, the requirement for like the bed top, which we're investigating right now, is it has to be closed cell. Nothing can absorb anything. So basically, what's that?
No liquids.
Yeah, no liquids. It just can't absorb anything because, yeah, like she said, we can expect them to spray it down, sterilize it, and then, you know, throw a sheet over top of it, and it's ready to go. As long as it doesn't soak up any biochemicals.
And now, when we were researching, we came across like just wooden planks that they were currently using, operating, you know, on top of like a kitchen table kind of thing. So this is definitely a vast improvement over that.
When you're having this challenge, did you subdivide the challenge into smaller tasks, or did you all work as a group on every task?
I think it was a little bit of both. When we first started out, the engineers outlined a task list of what was the most important and difficult things that we needed to accomplish first, and so we tackled those, and the business students kind of moved into working on other things while the design students researched materials. So we were all working together, but still on separate things, kind of dividing it, but still coming back, and that was really important in our meetings, that we all got to talk and we all got to inform each other of what we were working on and have input into what the other groups were working on.
I'm going to interrupt here. I'm sorry. Let's please acknowledge once again